So, I'm here to tell you about a stack that has the productivity and developer focus of Ruby and Rails. But in comparison to Ruby, it is quite performant. It brings concurrency and parallelism that blows Node.js out of the water, honestly. And it's a high-level language working at an expressive abstraction level, in contrast to, say, Go or Rust. In the ecosystem, we have an opinionated web framework that is both very productive and highly concurrent. It brings with it a database layer that is both novel and clear and kind of leaves ORMs in the rear view. And beyond that, we have a front-end web UI solution that eliminates the need for writing JavaScript, while bringing actual immutability and functional programming that leaves React kind of jealous. It is your absolutely normal, everyday web development, but better at every step. So this is what reimagining your foundations can do for you. This is what a community and an ecosystem can actually achieve. Built on an almost 40-year-old foundation of Swedish innovation, it has very deep roots and very high branches. It is used by unicorns, gaming giants, and telecom for its scalability and its performance. And it's used by startups and indie hackers for its velocity and its maintainability. It makes it trivial to do soft real-time. It lets you do audio and video easily. It even lets you run machine learning inference, and it simplifies your infrastructure. It also has a nice IoT framework. A recent Stack Overflow survey says that the developers working in the language are among the best paid and the most satisfied. I'm Lars Wikman. I run a site and a business called Underjord.io. Let me tell you about a language called Elixir. So I just made a bunch of claims. It might be a bit exaggerated at times, but generally solid. I want to back those up throughout this talk, but just to show that I'm kind of not blowing smoke or throwing unwarranted hype around, the hype is warranted. I'll give a little bit of context on who I am and my background before we move forward. So I'm a self-taught web dev. I came up through Perl, PHP, Python, JavaScript before I found Elixir. I've done about 25 years of programming, mostly in a web context, but all over the place. I've done 6 years of Elixir, 4 of them professionally. I have learned it, I have used it, I have taught it, I have recruited for it, and I have contributed to its ecosystem and community in a variety of ways. Now, since I'm a very enthusiastic person, it is quite okay to take everything I say with a grain of salt. If you need to, if you feel skeptical, that's all right, I don't mind. Just look into what I've been saying and see for yourself, see how you like it. All right, I'm going to curse myself by starting with a demo, because it's easier, or it's better to show than just tell. So with any luck, this one has started. Okay. Now, I need the microphone here, so I'm gonna have to stand over here. Let's see, and click, otherwise it doesn't get mic permissions. So, all right, so by starting out, it should be able to show what I'm saying on the screen, which is kind of basic, it's kind of neat, but this is all a web app that's listening to my microphone. And there's very little JavaScript here. There's a bit of JavaScript for opening the microphone and then shipping samples to a backend. The media processing, or rather the UI, is all driven from Elixir. The media processing is all Elixir. I don't have to worry about FFmpeg. It is involved, but I don't have to worry about it. And I can get a lot of interesting detail about the media processing as it is going past, which is a tricky bit to do in FFmpeg. So if I tell it to enable the fancy waveform, it'll just take a minute. And with any luck, yes. So now the media processing pipeline is feeding the UI to tell it to draw a nice waveform. This was fun to do in SVG. Also, the machine learning model that's listening to what I'm saying and trying its best to show it to you is also run entirely from Elixir. There is not a trace of Python in this project. And all of these pieces, the UI, the media pipeline, the parts of the media pipeline, the machine learning model, all fall under the same actor model abstraction. So there is not kind of 4 different paradigms of how to use the code. It is all kind of coherent, which I think is kind of nice. All right, let's get rid of this thing and proceed. So let's talk about Elixir. But to talk about Elixir, we have to talk about languages, so programming languages, runtimes, and design. When you create a programming language runtime, you make choices that enshrine trade-offs, sometimes intentionally, sometimes by accident. So Ruby and Python are known as high-level languages. Many people find them very elegant. They are very dynamic. They're incredibly mutable, super flexible, and as a consequence, they are dog slow and terrible at concurrency. This is also well known. It's not really something that's usually argued. Java and .NET, I consider them kind of like everything plus the kitchen sink languages. They are general, they're generic, they are safe, they are okay everywhere, they are kind of exceptional nowhere. And the reason why they are fairly fast and performant is mostly due to large companies pouring immense resources into optimizing them rather than a particular design choice that was made. Node.js V8, high single core performance. It has a concurrency model. It is superbly performant if you are doing I/O. That is, if you're not doing any work in it. And if you're doing CPU inbound work, it slows down significantly and has a bunch of poor side effects. It is as fast as it is due to immense investment, again, from companies that rely on it being fast, not due to any thought-through design, famously designed in like 2 weeks. Elixir builds on top of Erlang and the Beam virtual machine. Erlang was created, Erlang is sometimes known as the Ericsson language, which is, so I spoke to Robert Verding, who is one of the creators recently, and it's like, yeah, that was convenient, but honestly, it was because of this guy, Erlang, the mathematician, much like Pascal was named after a mathematician. But it was an effort to build a high-level, opinionated language for solving hard problems in the telecom space. And the telecom space was probably one of the most advanced technical spaces at the time. So the requirements were roughly this: concurrency, consistently low latencies, or what we sometimes call soft real-time, high availability, hot code updates to running systems. And depending on how much time you've spent with like design of languages and stuff, this is a pretty aggressive laundry list of features. So if you're trying to build a good concurrency API, you very often end up doing shared nothing and message passing, because the option is shared state and some kind of locking mechanism, which often gets you into trouble. If you want performant, simple concurrency designs, usually you end up with shared nothing and message passing. So Erlang became a functional programming language because it wanted immutability. So immutability is built in. You cannot produce shared states in the normal space of a program. And it implements something called processes as the primary isolated processes as the unit of concurrent execution. That's a thing to remember. And the only way these processes are allowed to communicate is message passing. So these are language primitives. Some would say Erlang implements the actor model. The actor model was not something Erlang creators were aware of. It is similar to the actor model. The theoretical actor model is very rarely considered these days. So when I'm talking about actors and the actor model, I'm talking about what Erlang actually implements. And immense multi-core performance came later. It was a side effect of the initial design. They built for concurrency, they built for low latency, they built for distributed execution across multiple nodes. So when CPU trends changed and we started adding more cores, many languages struggled. Erlang already had processes isolated. You just spin up more schedulers. One per core. You're good. Robert Verding, one of the creators, as I mentioned, has this first rule of programming. Any sufficiently complicated concurrent program in another language contains an ad hoc, informally specified, bug-ridden, and slow implementation of half of Erlang. You could absolutely say that the Erlang team had a bit of an attitude, but while it is kind of funny, kind of rude, it is also kind of true. You will find a lot of projects that implement something towards Erlang, but don't get there. Now, the Beam VM that Erlang runs on has proven itself over and over again. First at Ericsson, but then at WhatsApp. WhatsApp is entirely Erlang. Discord, entirely Elixir, aside from some Rust. Blizzard, Riot Games, AWS, and many, many more. It is capable of spawning millions of lightweight processes for concurrent work and distributing workloads across a global cluster. So Erlang has been the solution for many niche, cool products and projects, and not so niche products and projects, but it has been kind of the secret sauce. It has not been something people are well aware of. It has often been used for hard problems, but it has never achieved wide public popularity. But it is a very different design. It's making very considered design choices compared, I would say, to Ruby and Python, or and compared to, let's say, JVM.NET Node, it is performant for its type of workload. It's highly performant for its type of workload, especially compared to the amount of investment. Ericsson has not poured Google amounts of money into Erlang. And what is that workload? Services. It was built for services. And now everything is services. The web, as we know it, is services. So Erlang has kind of a role to fill there. So Elixir runs on Erlang, but it was created by a Rubyist, Jose Valim. And he worked in Ruby, but was looking for something more performant. So if you've done Ruby, Elixir will seem very familiar. But it is, under the syntax level, it is quite different. It is a high-level, dynamic, functional programming language, whereas Ruby is very much object-oriented. And this is semantically entirely equivalent to Erlang. What is probably the most important part is that people consider it much more approachable because it looks like regular programming, whereas Erlang has very different roots. So as a modern programming language spawned in the last 10 years, it has a lot of good tooling. So we have Mix, which is our CLI tool for doing everything, but project generation, builds, dependencies, and task running, that kind of thing. We have IEX, which is a shell. It's a REPL. It pulls in documentation. You can write your code, try things. You can connect it to a running system. You can paste new code to a running system. Don't do that unless you really want to. It's a very, very good REPL. Then we have Hex as a general notion, and then Hex phinix.pm, which is the package repository, and hexdocs, which is the documentation repository. Both of these are really best in class, and thankfully they also support Erlang. So the Erlang ecosystem has kind of flowed along with the Elixir system in this regard, which is nice. We have EXUnit, which is a testing framework. It's very comprehensive, but quite simple. It's really, really fast because it can run things concurrently and in parallel. It also does some nice things with like doc tests. So all the examples you find in many Elixir libraries and the standard library that show you how to do something are also tests, and they are run to ensure that they actually work. We don't have the time to dive deep on how Erlang achieves like legendary reliability and resiliency. It is known for putting up 9s, and there's a lot of discussion around this, but it is very well known for that. Elixir uses these foundations, and if you want to read more about it, I would suggest looking up supervision trees, which is a good starting point. I have written a blog post series called Unpacking Elixir, where I go into the Beam Erlang, and from an Elixir perspective, I cover this, among other things. But it's a bit of a big topic. But fundamentally, it isolates where problems can occur and let you design strategies for your system to be self-healing. As you start out, you don't really have to care about it. Most of the libraries do this for you. Now, we finally get to the web. The Phoenix Web Framework was started by another Rubyist, Chris McCord. And in Ruby, he was experimenting with doing real-time web UIs that were driven from Ruby, and that was very slow and very difficult. So he jumped at the opportunity of using a language that was familiar but more performant. They started out with building out Phoenix itself, which meant they built out basically a common MVC framework. You'll recognize it if you've used one. But of course, it utilizes Erlang's massive concurrency and parallelism, so you have that, and then you have heavily optimized templating, which means server-side rendering is really, really fast. And also, it's really good as an API, because Erlang is very good at services. Now, in a recent move for simplicity, and this is a little bit controversial, they ripped out Node and NPM by default. So instead they ship ES-Build and they ship Tailwind CSS as standalone binaries, and they're managed by Elixir libraries. So you don't actually have to rely on the NPM ecosystem. And this was honestly done mostly for the sake of the Phoenix core team, because half their time was spent debugging people's problems with Node and NPM. I applaud the change. I think it's a nice piece of opinionated choosing. But if you need JavaScript and that ecosystem, which is absolutely valid, then you can absolutely plug it back in with the normal methods. So. Then they moved on to actually using the real-time nature of the Beam and exposing the actor model more clearly to the browser. This was Phoenix Channels. It runs over WebSockets or optionally long polling, and it essentially allows you to do a lot of what WebSockets typically do, but with a little bit of nice abstraction on top of it. And as they were building it out, they wanted to see what it was actually capable of. So they made an effort to push it as far as they could on a single server. And they documented this in a blog post, and spoiler on the slide, but they reached 2 million concurrent active connections, actively chatting on one server. And then they called it kind of good. They were fine with that result. So fundamentally, we have this really capable web framework with some unique features in the terms of Phoenix Channels and Phoenix Presence that we can't get into right now. But now it's time to get a little bit disruptive. So imagine a full stack paradigm that covers 95% of your common use cases and does that by putting the server first and pushing the actor model all the way to where it can just smell the browser. So you marry, no, hold on. This is the type of thing I keep track of. lose track of. So with real functional programming and actual immutability and optimized diffing to minimize data over the wire, you get this real-time interactive web UI in the front end, which doesn't require you to write any JavaScript, and you can just write Elixir, and that's Phoenix LiveView. And it has inspired a bunch of copies as well. So you might have heard of Laravel's LiveWire, for example. I believe Hotwire or Stimulus Reflux, I always mix those two up in the Ruby space. There's a Django variant as well, which do similar things, but their runtimes are not quite as suited to it, so they have limitations. They're still really useful because it is a kind of simple design that covers immense ground. It marries a small JavaScript library with a WebSocket and an actor that holds server-side state. This is very similar to what all front-end frameworks tend to do, except for the state and the template handling is done on the server. So you get to use the fact that Erlang and Elixir and the Beam are great at managing state, great at managing and operating concurrently, and you don't have to maintain APIs, contracts, clients. There's a ton of stuff you just don't have to write. So this is time to market. This is good beating out perfect. This is a keep it simple, stupid approach. It is doing more with less. It is relying on the abstractions and leveraging the runtime that you have for better results. This is what healthy abstraction is all about, in my eyes. Of course, it's not great for offline first. There's a server involved. There are also other applications where you might not want to choose this tool. It is not for everything. Highly interactive. I wouldn't do WebGL with this. But overall, you can also mix it with other approaches. So, and it grows beyond the prototype. It has components, it has slots, it has most of the facilities you expect from a front-end web framework. It also has a file upload implementation to die for. And if you use it, you don't need to write any JavaScript, or almost any JavaScript. But you can, if you need. There are extension points and escape hatches. This community is very pragmatic in that regard. This is a community of builders by builders. I've been to ElixirConf, and it is dominated by people that use this language and the frameworks around it to just get stuff done. And this carries out through the history of both the communities that came before it. Erlang is an industry language. While it has always been studied with great interest by academics, it did not come from academia. And Ruby was always a tool for creation. And Elixir is a synthesis of these cultures and of the software they created. I consider Elixir to be functional programming without the pretension. There are no monads required. You don't even have to find out what one is. And to me, it's a workhorse language. It replaces your PHP, your Python, your Node.js, your Ruby, and it can do multiple things at the same time. If you work with Elixir, you join a community that was spawned, grown, and has progressed without a megacorp at the helm. It is an ecosystem where code rarely churns or changes. The language was considered largely done a number of years back, like 4 years, I think. And that announcement was met with massive applause at the time. No one really wants their language to constantly change if they're kind of happy with where it is. I think I had another point to that, but moving on. An example of things that, oh yeah, innovation happens generally outside the language itself, in the ecosystem around it. And this is one example. The membrane media framework that I mentioned during the demo without mentioning its name. So generally, as a web developer, you end up dealing with video at some point and needing to convert it to web formats. Maybe you're getting it from mobile phones, maybe you're getting it from somewhere else. But everyone reaches for FFmpeg, and then you set up a queue, then you set up a worker off that queue, then you shell out or use a library to wield FFmpeg, just wield FFmpeg at it, and then you wait for it to complete, and you try to do something with the output. And you should, like, FFmpeg is a fantastic tool. This is not a slam on FFmpeg, but it is really hard to manage. And if you're trying to do something with live streaming, you start that FFmpeg up, and then you just pray that it doesn't crash. You don't have a lot of insight into what's happening. You don't have a lot of control. You don't have a lot of options if it goes wrong. Membrane is kind of different. They didn't go out and build a set of FFmpeg bindings. They did that among the rest of the framework that they wanted to build, which was a robust media streaming framework for live streaming. This is just in line with the Erlang approach. You solve the hard problem, and the rest kind of falls into place. If you can do live streaming easily, you're already doing offline transcoding, really. So now that team is off solving WebRTC for us. And if you know anything about WebRTC, you know that's quite an undertaking. So they are solving another hard problem. Membrane generally works. It would be nice to have kind of a wider support and stuff, but it's a good project. Now, another example. The Bumblebee project, which builds upon the NX project. NX stands for numerical Elixir, and that's kind of an audacious act of taking a stab at the absolutely worst part of Erlang and Elixir. They are not fast at number crunching. They shouldn't be. They're high-level, functional, dynamic languages. So what they did is they built an abstraction where you can construct and define computation graphs for your complex mathematical work, and then compile that down to existing accelerators that other organizations have poured millions into, such as Google XLA, soon to be OpenXLA, I think, TorchX, and other backends. This means you can port machine learning to Elixir, which was not what I expected when I started doing Elixir. Bumblebee is kind of like Hugging Face transformers for Elixir. It is a library that makes it easy for mathless web devs like myself to just casually pluck machine learning models off the shelf and just shove them into my web app. I can take a model for sentiment analysis of text and just run that on the CPU. That will perform fine. Well, you've seen speech to text run just on the CPU of this lightweight laptop. That was part of the demo. And of course, if you have a GPU, you can go for Stable Diffusion or Llama 2 or Mistral, any of the kind of state-of-the-art current open models. So that's all available to you, and Bumblebee gives you abstractions that are just plug and play. Now, a common challenge in machine learning is orchestration. Especially since you're running Python, you don't particularly want to run your machine learning work on the same node you're like doing web serving or anything. So you have these GPU nodes, and you need to distribute the work to them. Typically, you reach for libraries. A common one is Ray, which is built in C++, like much of the Python machine learning ecosystem. And that pretty much implements the actor model. So NX already has access to the actor model. So they just shipped multi-node, multi-GPU as part of the everyday development. It was like 500 lines of code. Another thing when we're dealing with GPUs is utilization. So you want to fully utilize the GPU resources. You have these big GPUs. Maybe you don't have a massive model. Then you want to run work in parallel. So you do batching. And batching is apparently tricky to get done in Python, or so I hear. I haven't done it. But it ships with NX, just built in. Usually, when data companies develop their stuff, they do that in code notebooks because you're working with data scientists that are not necessarily developers. Traditional code notebooks are not shippable. They have trouble with reproducing. So they're not usually not reproducible. It's not that they can't have kids. And they're generally not that fun to work with. We have LiveView. We have our own. That's a theme in Elixir. We have our own, unfortunately, sometimes. But they're very straightforward. They're fully collaborative. Think Google Docs. You can sit and write code and documentation together with your colleague and then run it. You can connect them to active production nodes. You can connect them to anything you want, really. They are straight text as a storage format, and they can be shipped as multiplayer apps. There's so much functionality in LiveView at this point. It's a really, really interesting project. And like this whole NX thing, it's just this removal of a whole set of problems with the ecosystem. Like sometimes you do need to do number crunching, and historically people have reached for Rust, which can plug into Elixir to solve that. NX means we don't always have to do that, especially machine learning. Now you can just plug it right in. And right, so I'm talking about this machine learning on the web track. So for me, I run a consultancy, and all of my clients are currently talking about AI. I don't know about your workplaces, but there has been a lot of conversation about AI recently. And for me, I'm very happy. Like I don't see that going away in the near term. I don't know about the long term. But being able to tackle this in Elixir is a big boon for me. And I think this type of deep stack development, as I've heard it called, where you, like full stack is not quite enough and you have to go sideways off into data and ML, I don't think that's going away in a hurry. So being able to use Elixir as an option to Python suits me very well. And I don't really dislike Python. I've done tons of years of Python. Python is nice. But more hands-on, we can use Nerves for embedded Linux. Nerves uses embedded Linux as a launching pad for bringing up the beam, Erlang, and using fundamentally the beam as your primary operating system. So you get resilience, you get right in a high-level language. You don't really sacrifice a ton of performance. You can use Phoenix, you can use LiveView. There's Nerves Hub, which is an open source fleet management tool, which will handle your signed firmware, binary diffing of payloads, remote console for troubleshooting. It's wild. And Erlang already has escape patches if you need to go low level for a minute. So normally Erlang supports C, but the Elixir ecosystem built out Zig and Rust as well. Deployment. We deploy just like everyone else in a Docker container, typically. But you can also compile a release, which is kind of an archive. It's similar to a static binary, but it's more complicated. And it is more complicated because Erlang and Elixir support hot code updates. Most don't use this facility because there are easier options right now. But if you want to hear more about hot code updates, because it's very interesting, I would look up old Erlang talks from WhatsApp, or I'd listen to Beam Radio episode 12 with Brian Hunter called Punking the Servers, where he gets into beam shipping and a bunch of other interesting stuff. We also generally deploy with clustering enabled, which is also called Erlang distribution. This means that all our nodes are connected, and they can pass messages transparently inside of the entire cluster, which means we don't need a lot of external tools for coordination or anything like that. So how do we deploy? We deploy just like everyone else, but slightly better. There's a higher ceiling of potential. There's a lot you can do, but the skills you have with operations already will serve you quite well, especially initially. Observability and introspection. This, I think, is very important. This is day-to-day. How do you run this stuff? How do you live with it? We support OpenTelemetry all the way through. There's good tools for logs, metrics, and traces. But the Beam VM lets us do much, much more. So it has tons of facilities for introspecting and asking questions of your system. And Phoenix ships with one of a UI for it built in. Phoenix Live Dashboard, that's that thing over there. So you can see a bunch of memory allocations. You can look at the running processes. If you introduce a memory leak, you can just sort by memory usage and see, ah, that's the one. It's that function. Oh, I did that. And if you need to know how a function is called, what its inputs are, what its outputs are, what its timing is, you can actually just connect a shell and start asking some questions. Or you can use this if you're just going for timings, which is the Orion Dynamic Distributed Profiler web UI thingy. You just install this library, put it under your super admin protected parts, and you can trigger traces across your entire cluster and get histograms of the performance. Erlang and Elixir has this weird ability to absorb the work of other tools. You generally don't need as much infrastructure when you're using it. We typically don't need special queues, caches, pub/sub mechanisms. We generally don't need a reverse proxy for performance or for protecting our application server. So we don't generally have Redis, RabbitMQ, or Nginx running. Erlang even ships a distributed database in the standard library. It's called Amnesia. It's very cool, but we tend to use Postgres because Postgres is very good. Now, LiveView kind of follows that trend. It takes a big bite out of the front end and just lets you make a self-contained app where essentially all you need to do is write your Elixir code. And with preemptive multitasking, doing a bunch of different types of work in your app is still smooth. It doesn't disrupt the other pieces of work. Your application can be your whole system. This is way beyond a common monolith. Of course, you could do microservices with Elixir as well. Plenty of people do. Now, when you line up all the kind of unique advantages and upsides and potentials of Elixir, Erlang, and the Beam, it tends to sound like something futuristic. My expectation, if I heard it for the first time, would be kind of, okay, and next they're going to say, we're very excited to share this roadmap with you, and we would love it if you signed up for the announcement of our developer preview. Enter your email here, sign up. You expect it to never come to pass. Fortunately for us, someone decided to make something futuristic 40 years ago. And then Elixir shone a spotlight on it 10 years ago. It already exists. I use it every day. This is my primary breadwinner. This is all I do. Or in the words of William Gibson, the future is already here. It's just not evenly distributed yet. Thank you for listening.